Hello, everybody, and welcome to today's vOLTHA TST meeting. Thanks for joining. It's first meeting after the 2.7 release. As usual, the call is public and recorded and will be shared on YouTube, so please be mindful of the comments you make and the information that you share. First of all, I'd like to get resolution, or at least some more comments and some more thoughts from everybody around the presentation that Ken made on the Kafka to gRPC swap, and what would be for everybody here a reasonable release target, bearing in mind that this would have to be approved by the operators as well. Ken, something you want to share with the team?
No, but I don't know. Did everybody saw the presentation last week to be able to provide comment?
I saw.
To me, it seems a work very well done and seemed to prove very valuable. As I said, I have some thoughts about putting it into 2.8, and we have to check with the operators if they want this within.
I just have a question on this. Why do we need to check with the operators?
Because it changes the deployment model, and some of them already went in production with the current Kafka deployment model, and maybe some of the procedures and the operation team have been briefed and trained and, you know, the usual things on the current Kafka-based deployment model. It's just something that I would not feel comfortable doing without their approval. Maybe I'm wrong.
I think they can be consulted. I'm not sure that we require approval on this. I think this is architecturally the right thing to do for the project. I think doing it in 2.8 before we cut a long-term release is probably appropriate, because if we cut a long-term release on Kafka and then immediately change to gRPC, that is going to make any bug fixes on that long-term release difficult to port between the two versions, particularly if they're around the communications area. It reduces the code complexity because it removes a lot of the customization we've had to do around gRPC over Kafka. So that simplifies the code. And normally, when you simplify code by that way, we're not trying to replicate a behavior in a different library, that also reduces the chance for bug surfaces, right? Because we've eliminated a section of where bugs can happen. So I think actually 2.8 is probably, before the long-term release, probably the right time to do it. Additionally, if we go to 2.8 and push this off to 2.9 or past long-term release, all this work that's been done so far essentially is going to have to be almost redone, because a rebase is going to be problematic as things change over time. So again, my opinion is right now it is kind of the right time.
Okay, I agree with your points, David. I'm a little worried that maybe the operators won't, but maybe I'm wrong. I'm just maybe a little bit too conservative. But I agree that if we want to do it within this release, now is the time.
It won't be the first time people disagree with me, so that's okay.
I'm generally concerned when people
we lost you, Theo.
Oh yeah, it was nothing important. I was just saying that I think it's either before the LTS or this will be a radical change, and maintaining it, both Kafka and gRPC will be a lot of work on us. So since we're planning to do an LTS, I think we should put any big change in before we do it.
Agreed.
I also have different feelings about this feature. I like it. I think it's a good change for the stability of the product and simplicity of it. I believe it's good. But as Matteo said, I think it's a big change, and I'm not sure if personally, me and Netsia, for example, when thinking the deployment in the telecom field, I mean, this is really pain because a lot of tests should be done probably, and the change to deployment model, the CI, the test environment, etc. Big change. So I'm afraid of it, actually.
I agree. We need to do a lot of testing, by the way. Absolutely agree. I just think the maintenance of it, if we don't do it now, it's going to be a problem. If we release with Kafka for the LTS, it just means this change is not going to happen for a while because we're going to have to be able to maintain that LTS for whatever this period is, a year.
Yeah, my comment is whether we do it now or later, it will still be a big change. It still needs a lot of testing. And so the amount of work we will have to do quite a bit to make sure it works. So that's a given. Whether it's now or later, that has to be done. The thing that I've observed is while I was doing that change, it's really simplified the code. It makes things much easier, especially for the adapters and especially the ONU adapter. If we just delay and just keep adding functionality to the ONU adapters, then it will just make it more, it will be harder to troubleshoot in the future for just Kafka. And it just make the code more complex going forward. Like it's harder to debug. So in a way, we'll be saving time down the road if we migrate to gRPC as the earlier we can. The only thing I will have to say, and the last time I didn't put that in my slide, is a big thing also depends on the adapters that are out there. Like I look only at the OpenVOLTHA and OpenONU Go adapters. If there are any adapters that are there that will need to interact with the core, then they will have to interact with gRPC. So it's really all those adapters ready to move from Kafka to gRPC as well. So that's something that needs to be considered.
Yeah, that's probably the biggest concern for the operators.
Is it possible that these changes can be software selectable, initially, so that at some point you could deprecate Kafka in a graceful manner?
I was trying hard really to see if we can do that.
Yeah.
Just make a code spaghetti, seriously.
Yeah, I would avoid that. It's just going to be a pain, and if we decide to do it, it's going to be a one-shot thing. We do it, and everybody has to come up with the implementation, and it's going to be painful. I know already, and those are parts of my concerns. But if we do it, and we don't look back. That's my take.
And one thing I have to say, if an existing adapter want to migrate from Kafka to gRPC, pretty much there's not a tons of work that are required in the adapter, because everything that needs to be done are in the libraries, and the OpenONU Go, the code is there. So that can be used as a template. But in terms of changes, like when I was doing those changes, it took me a long time to get the library right, to get the core right, and then to get the OLT right. But when I had to do the change in the ONU, it took me maybe 2 days. And I'm not very familiar with the ONU code. it just took me 2 days to get it up and running. So it's not a huge amount of work
Yeah.
to start with.
Well, personally, I'm not worried about the work involved, so.
Sorry, Ken, does that hold true as well with the OpenOLT adapter?
Yeah, well, maybe for the OLT, maybe it took me like maybe a week. The reason was because it was the first time I was trying to do some changes in the adapter itself. But once a change is done in an adapter, then it's similar template in all those other adapters. So there's not a huge amount of change. The only thing I have to say is like we have to do a lot of testing, right, to make sure that it's everything is right. But if the code base is there, then the migration is not a huge effort.
Yep.
Yeah, I think all the communication was abstracted in the library, so it may just be a matter of changing the interface in the code that is using the library.
Okay, so let's let me do a couple things. One, investigate this with the folks at Atran, and maybe I'll ping you, Chip, as well, to see if this is something that you guys feel up taking in 2.8.
Also add NTT to that list because they have the
Oh,
econ.
indeed. Yeah, and there are a few others that I know of that might have something here. So that's an action item on myself, and also ping the operators outlining this change and the reasons behind it, the very valid reasons behind it, and why it should be best if done now. So I'll take that on myself to do this possibly within this week and get back to everybody next week with the information. Would that work?
For me,
That's reasonable.
yeah, if anyone wants to go in the details of that migration, like anybody on the adapter side, then we can have a separate meeting. I can go in the details of it as well, if anybody is willing to need that information.
Will do. Okay. So next up is VOLTHA 2.8. We released just 2.7. This is a minor update from myself. We're still putting together the roadmap for 2.8. There's a few key things that will go in, but will need to be discussed with the operators before. We have a list. It's not the finalized list, so that's why I'm not sharing it right now. The target date is June 30th. So a 3-month schedule for this one. But if we get that list that we're putting together in the release, we will call this LTS and be done with it. So that is our goal. I'll most likely have the time to share more information about this next time, because we're targeting an operator TST call within the week, and I'll send out more information about that in a couple of days whenever we settle that. So yeah, that's the current status of 2.8. I know some people are already working towards targets of 2.8. For example, David started putting together some hardening of the images of the Docker images. That's great. So thanks for doing that. I think there is some meat that can be grilled during this week before we get a final commitment for the release next week for the roadmap. Okay. Any questions on that? Okay. So next up, I just want to get the status of the reconciling, the device reconciling state that is updated by the core. So maybe David, do you have anything on this?
So there was some discussion. I was just looking to see if there's now there's some discussion on this around the patch set. Let me try to jog my memory here. The idea was that a reconcile could be started and then a reconcile could fail, and how's that tracked, and how's that retried, and how's it surfaced. And so the discussion came to be around, hey, we need to understand and have as part of the status or state, if you will, what's really happening. Are we in a really reconciling mode, or are we in a reconciling failed and we're doing the back off? And so that's where the back off came, is kind of like how Kubernetes deals with some failures. It lets you know it's a back off state, get a retry. The second issue around this quickly came, though, because of the value that is being set around reconciliation and back off. This is the state value, which I think, other than the initial state for a device, is actually set in response to an event from the adapter, as opposed to the core setting it. So reconcile and reconcile back off breaks this pattern because it has the core changing the state. And so I thought that was a significant issue. If we're going to actually break that pattern, then it needs to be discussed at the TST level. And that's kind of how this got surfaced to this meeting. So my understanding is at least some of the work is done. It hasn't been completed because it was waiting kind of on discussion at the TST level to decide if this state, if we're going to be okay to extend the pattern, if you will, that some states will be set by the core and some states will be set by the adapter. There you go.
Just one more thing to add, maybe to that. It's pretty much during reconciling phase. So what happened that, like, let's say the adapter got rebooted, comes back up, the core detect that and send a reconciliation of a given set of devices to the adapter. What the core does, it set the operational state of the device to be reconciling and expect the adapter to change the operational state after it has reconciled the device. So if in a way, when the adapter was not there, we don't really know the actual operational state of that device. So after reconciliation, the goal is for the adapter to actually change the operational state to be the actual one. But one is, during that phase of a device being reconciled, there's a check in the core, or there will be a check in the core to prevent any operation on that device, other than maybe delete. And if during reconciliation and the core has set the device state to reconciling, and for some reason the adapter either doesn't update that state or there's a failure, what action should the core do? Should the core just back off and keep retrying to reconcile? And that's one option. Or should we still prevent all action on that device, even if it's not reconciled correctly?
Right, and again, my opinion here is if the device is not reconciled correctly, then making any changes could potentially make it worse, which is why I personally think having states in the system understands what's going on and can act accordingly is probably the right choice. That's again my opinion.
The question I have for the adapter folks is like, what does it mean to do an OLT reconcile or an ONU reconcile? Is it only the checking the state, or is there anything else that gets done during a reconciliation?
So I can speak for the ONU adapter side of things. There are a couple of things that can happen. One of them is that once we connect back to the device that went down or the adapter went down, there is an MDS check. If that MDS is the same, so there is a counter. If no other messages, nothing happened on the ONU, and basically the state is the same, effectively nothing happens. So that's done. There's no effect on the device. If instead that check is false, meaning that there were some changes for some reason, we don't know why, we just reprovision the device with the known configuration that is gathered from the core. That is gathered from the TCD. So that's the ONU adapter, and to the best of my knowledge, that applies as well to the OLT adapter. Best person would be Girish for this. Did that answer your question, Ken?
Yeah. So what would create a situation where either we don't get a response from the adapter for following a reconciliation request?
To the best of my knowledge, there shouldn't be any, because even if the adapter saves the reconcile state within the etcd as a state update, and it goes and then fails and restarts, it should pick up the reconciling state and still proceed with the checks and eventually reply to the core. If the device goes down and the adapter cannot complete the reconciling phase, it will need to probably send a reconcile failed to the core, or some other type of event to the core, maybe device disconnected, and then the core would have to handle that to either delete the device or like stop the reconciliation. I'm not sure what the outcome of that would be.
Okay, so if there's a failure in reconciliation, in that scenario, will it be worth for the core to retry reconciling?
I guess it depends.
If
depends.
the reconcile in the adapter at its simplest form, I mean, if it's already reconciled, it's a quick check and done, right? So a retry is almost a no-op, or very little processing, right? Is that correct?
Yeah. Well, okay. So I hear there needs to be a couple of changes in the core still to achieve this. Is that right?
I'm just trying to figure out what kind of change we need to do in the core following a reconcile failure. Like, should we just back off and retry, or is there some other action that needs to be done?
So if we don't back off and retry, the state in the core should show reconcile failed. And then what happens in that scenario? What's an operator to do? Don't they have to manually retry reconcile?
It also depends, to me at least, on why, like what happens within like the reconciliation state. For example, if a device if the core gets a device disconnected event during reconciliation, which is a perfectly valuable case, that's a scenario that we need to handle.
If the core gets a disconnect while we're reconciling, I mean, what would be the way to handle that case? Would it be to reattempt reconciliation, or
No,
would it be a different
if a
action?
device gets this, you need to wait until device reconnection, and then you need to reconcile.
So in this specific case, when you're talking about a device disconnect, so basically what will happen, it will be the adapter will send an event to the core saying that device have changed connection status and has become unreachable. Is that what you mean?
Yes.
Yeah, I guess I would argue that if we have a back off, even in that state, that's fine. We get a disconnect, we get the disconnect and we back off, and then sooner we don't necessarily need to wait for the reconnect event. We back off. We do a wait 5 seconds, then try again. If we're still not connected, fine. We fail again. We wait 10 seconds. Right? It's an incremental back off, which is again the pattern that we're seeing in Kubernetes. Right? If Kubernetes can't talk to a pod, it doesn't keep pinging and wait until that connection's up. It just says, okay, I'll retry a little bit later, and does an incremental back off. I'm not sure why that wouldn't work in this scenario as well.
I think it might. But so
otherwise we're going to be special casing. Oh, we're disconnected. Then we're going to wait for this trigger before we reconcile, or it's a different special case where if we just do a back off, it's kind of we do the same thing. A single pattern.
Okay, so one question: what's the status of all of this? Like, what's implemented? What's missing? Like, what are we talking about?
So yeah, Maninder had implemented the core, I think, setting the state to reconcile and setting an event. We haven't implemented what happens when it fails in the back off, because again, we wanted to have this meeting first. So right now, if there's a failure, I think it's almost a silent failure in the patch set. I can't remember. I'm sure there's a log of some such, but it's not a state change. And again, that becomes an issue because even setting the state in the core to reconcile is a little bit different than what we had originally talked about for the operational state, where operational state is always set in response to an event from the adapter, except I think in the single case, which was like setting it pre-provisioned or whatever it was.
Oh, but so I'm still wondering, why should the core itself set it to reconcile? I mean, it's the OLT that knows what it's doing. It's the OLT adapter that knows what it's doing with the OLT, and it's the ONU adapter that knows what it's doing with the ONU.
The core sets it to reconcile and then sends the reconcile message to the adapter.
If the core doesn't send that, doesn't change that state to reconcile, then during that phase, any operation will be allowed on that device. So,
well, hold on. We're talking about two different things here. First is allowing operation on a device during reconciling state, which I'm completely fine not doing. We shouldn't allow any operation. But I'm still not getting why is the core initiating the reconciling state, while in my mind should be the adapter, because that's the guy that knows. Maybe the only case where the core can do it is when he himself is reconciling flows against the device.
well,
That's the only case.
Okay, so put it this way: an adapter has gone down and came back up.
Yep.
So it doesn't know what devices it's managing. So it needs to.
No, hold on. It does. No. It does. It has that information in a TCD, especially because of for this case. It knows what devices, what flows, what like configuration. At least the ONU adapter, I'm 100% sure of this. The vOLTHA adapter, I'm almost sure of it. So it knows.
Okay, so originally when that reconciliation was meant, it was assuming that the adapters doesn't know what devices you're managing. That's one thing. And second is, if an adapter went down and come back up, the data that we have in the core may not be the latest data. So that's why there's this reconciliation that was triggered from the core. So you can have an argument about saying that it can also be triggered by the adapter. What benefit do you see by having the adapter trigger that instead of the core triggering that? Because in the core, you could also...
It's ownership of a device. It's ownership of a device. To me, the core doesn't own the device. It's the adapter that owns it and is responsible to off talking to it. And the reconciliation state, except for the case where it's the core reconciling its own state, it's because something happened with the device or the adapter. And that is why, to me, the adapter should send it. And the core just in that case.
But if, I'm trying to understand this. So if there's a disconnect and a reconnect, the core, why, I guess I'm still struggling. Well, if there's a disconnect and a reconnect, you're saying the adapter knows what devices it manages. That assumes there's been no change on the core side during that disconnect. Is that correct?
No, the first thing so what I'm envisioning is that we shouldn't do any operation against a device that is disconnected. Unless
right, but is there a window that might take place still? I don't know.
Possibly.
I guess the question is if someone is seems to me anytime there's a reconnect between the core and an adapter, a reconciliation has to take place. And the question is who recognizes that connection up? And if that's the core, then it makes sense for the core to initiate the reconciliation. If nothing else, if we want the adapter to initiate the reconciliation, then we have to make sure that the core doesn't go to connected and reachable before it's set to reconciliation by the adapter. Because if we do it the other way around, there is a potential window.
So that should be the case. The adapter should come back, okay, or either the adapter comes back or the device comes back and says, okay, now it was disconnected, it was unreachable, it was something. Now I'm reconciling it. Now the reconciliation is done. Now it's connected and available.
Who drives that change to connected and available? Is that the core?
Adapter.
So the core will never go to reachable and changeable until the adapter says it is.
That is the current pattern, and I should like to keep it that way, I think.
Okay, that's
At least
fine.
that is my thinking.
So on a reconnect, the adapter is going to force a reconciliation before it updates the core to let it know that that it's ready.
Yes, effectively,
Okay.
I think in the OpenONU adapter, I'll have to check with the guys from the OpenONU adapter, but they're effectively masking the reconciliation before the core update already. So it's just, for them, it would just be the difference of setting the reconciling state and then setting the available, reachable, whatever, that they are now doing after the reconciliation happened.
Okay.
So it's just going to be a step of setting the reconciling, and maybe the core does something with that reconciling state. I'm not sure.
And if there is, so assume we get reconnected assume that the adapter sends reconcile to the core, assuming the core gets it. The core now has as operational state of reconcile. If there's a failure in reconciliation and connectivity is still available, the adapter, I assume, would set the state of reconcile failed, and the core would get that, assuming all communications are still up and running.
Yeah.
What happens in that case? When does it ever move out of the reconciled failed state?
It should be the adapter that has the knowledge of retry capability for this. I think that is my take.
But then we have different behavior potentially by each adapter, because one adapter could try an incremental back off, another could try it once and never try again. Another could just have a 5-second retry. It makes behavior dependent on the adapter implementation. Any consistency dependent on us testing, I guess, versus making it consistent through the core code. Adapter is no longer doing an adapter. An adapter is doing behavior, business behavior.
Not really, because the core has the capability to call reconcile device against an adapter. And that call needs to be supported by the adapter. So we implement our mechanism and then call reconcile device. And worst case, we just keep getting, nope, I can't. Is that what you're asking, David?
Yeah, well, I'm suggesting that if we drive this from the core, we get consistent behavior over adapter, and adapter stays what I'd always thought an adapter was, which was meant to be a very thin layer. Where if we drive this completely from the adapter, we start putting business logic, if you will, or logic, if you will, into the adapter that may be different for each adapter implementation.
No. Okay, I get it. So my take is the adapter should start the reconciliation by updating the core with the device state of reconciling. Hey, I'm reconciling this device because I don't know what happened to it. Then it either goes to everything is fine, or it goes to reconciling failed. If it goes to reconcile failed, the core will have a mechanism, exponential backoff, whatever, and that calls the reconcile device method towards that adapter to keep retrying reconciliation against that device. And this seems to me a pretty straightforward way of keeping the logic of backoff retry in the core, but the update of the device state to the adapter, which is the one holding the information, and we don't break our existing assumption that is the core updating, that is the adapters updating the device state and not the core. Am I making sense?
No, that makes sense. That just means during the exponential backoff, and thank you, I've been calling it incremental backoff, I don't know why, but exponential backoff phase, the state in the core is still reconciled failed. It's not, hey, I'm backing off and retrying.
I mean, we could have a self-update from the core of retrying reconciliation, sure.
That again then breaks the pattern.
Not really, because it's not an event generated by a device. It's the core that retries. I know it's a thin line. Or yes, we leave it to reconcile failed.
I like having indication that it's doing a back off in the state, just because I like the operator to understand what's really happening and not make that implicit. If that means the core has to update that state, I'm not. I guess I'm okay with that, because we'll see. The core would set it to reconcile back off and then send a request. And then if it succeeds, the adapter will set the state to okay. If it fails, the operator will set the state to
Why?
Go ahead, I'm sorry.
Why can't simply, so when the core starts retrying, it calls the adapter reconcile method. And why can the adapter set the state in that moment? In that way, the pattern is not broken.
We could, it would just be
a reconciler started, or whatever state we want to put it.
we could, it would just be that it would be a contract between the adapter and the core, which I'm fine documenting and saying that you have to do this. I'm okay with that.
Can you try that again, just so I understand?
So what I was saying is that the adapter tries to reconcile the device, no? And it may fail and updates the state to reconcile failed. At that point, the core starts the backoff to retry the reconciliation. But when we call the reconcile method in the adapter, doesn't the adapter set the state to reconcile started or reconciling? And so we could see that reflected in the APIs. So there is no need for the core to update the state in reconcile backoff.
Oh, so what you're saying is, if I understand correctly, when there's a failure, the state will go to reconcile fail, and then at some point, the core will call reconcile again. At which point, assuming communication's up still, that the adapter will set it to reconciling. So we'll see this toggle between reconciled, fail, reconcile, reconciled, fail, reconcile in the state.
Yeah, correct.
If there is a miscommunication, if the communication breaks down after reconciliation has failed,
reconciliation stays failed.
Reconciliation stays failed, and well, does the state ever get changed to something like disconnected, or is that just a reachable field?
Well, but it's not
that's an adapter
reachable
choice.
No, that
well, no, because the adapter I can't get to it.
The adapter is not there.
Yeah.
Oh, sorry, you meant an adapter failure, not the device failure. Sorry.
Or connectivity between the two fails.
Yeah, that's a good. I don't think we ever consider in the device state the adapter state. We're kind of mixing the two things, because that at that point the device state is that the reconciling is failing. The reason for the failure is that the adapter is not responding.
Yeah,
but that's not a device issue.
Yeah.
Today we don't have the adapter state, so that's something that we need to add.
Don't we have the adapter state in adapter list?
Not really. We have something that says like the last time that we communicate with the adapter, but we don't have an explicit state for adapters.
Okay, then that's a different topic. I don't think we should mix the adapter state with the device state.
Yeah.
Especially in the case in the OLT where if vOLTHA goes away, the data path still works.
A question I have, like for the reconciling per se, Andrea, you mentioned that the adapters that you know, they all are stateful and they all have the list of devices that they manage. Is that the case for all adapters? And what happens if we have an adapter that is actually fully stateless?
In that case, it would go and get the device list from the core. But that's an implementation detail. we shouldn't care too much about it.
So I don't think the adapters actually store a list of the devices, because if you look in the logs of the vOLTHA and open a new, there are a ton of call to get device endpoint.
They have the configuration they stored for each device, so
They have
can
the
get
configuration, but they could potentially derive the list, but they don't keep the list in memory.
Sure. Okay. Fine. Still, I don't see what the point is.
No, I was just asking you a question. That's just.
Okay. Okay. So
I don't know. I think we need to postpone this discussion to a meeting in which we have the adapter expert in the call.
Agreed, but still, I do think what we discussed is that we should be able, in the way we described it, not to have the core itself update the device state.
Are you just suggesting as a first patch towards an eventual solution, have it so that the adapter initiates a reconciliation, sets the state to reconcile. If it fails, we'll set the state to reconciled failed. And then the core in its state machine, when it sees reconciled failed, it can do an exponential back off, attempting to get reconciled fixed.
Yes, that would be my take. Yes,
I think that's a reasonable first approach. It does mean that the core is going to have to maintain that, hey, I'm trying to reconcile this device, and my back off period is X, so that if it fails again before it goes clear, what my back off time would be. There's some state the core is going to have to keep about that situation.
So let me summarize a little bit from a event perspective. Let's say the adapter goes down, the adapter comes back up. Is it correct to assume that at that time the adapter will change the operational state of a device, or all the devices it manages, to reconciling? We'll try the reconciliation. If it's passed, it will change the operational state to active, let's say. If it fails, it will set the state to reconcile failed. And at that moment, the adapter stops doing any processing on that device. So the core will start to initiate that reconciliation again with a backup mechanism. Is that correct? Or I'm missing something?
I believe it is.
Because what it means is when an adapter restarted, the code doesn't do anything until that we see a reconciled failure on a given device.
Correct.
Okay, cool. That makes sense. Works for me.
Yeah, I'm just trying to figure out how an adapter knows that he's restarted. I mean, because in the current mechanism, when an adapter comes up, he registers with the core, which says I'm ready for work, and he'll either see one of two messages. Eventually, he'll see an enable come across, which means he's enabling a device for the very. He's starting. He needs to start a handler up for a specific device, and he's the owner of that. Or he sees a reconcile, which says there's an existing device. You now have a responsibility for it. And that's a very simple mechanism, and it allows also multiple replicas and other capabilities in the future if you want to run multiple replicas of an adapter, because each adapter replica registers as a separate adapter. But if you have an adapter come up and he starts searching etcd to see if he's got work to do, that's just sort of a bit ugly. Does that make any sense?
If adapter comes up and sees if it has work to do, it's ugly. Are you trying to suggest that all action should be driven by the core, not by the adapter?
Well, the initial work is always handed out by the core, because when an adapter comes up, he registers. He says, I'm available for work. And if it happens to be a restart of a replica, then the core knows, hey, I previously assigned you a bunch of devices to handle. You know, here they are, reconcile them. You know, I mean, that's how it works right now. Mm-hmm. So if we stay with that, where the adapter just comes up and he waits, you know, he's basically coming up from zero. Either he's restarted or this is the very first time. He operates the same. And that allows the core later on, maybe an adapter fails and the core moves that, just fix an already running replica and say, hey, start handling this device.
I tend to agree with you, I think. Right now, I believe that the adapters essentially cache information in etcd as a performance issue, right? Because, hey, if I know what devices I'm managing and have all that data locally, I don't have to get it back from the core again. I think that's why they write the etcd around this stuff. But I could just as easily have them say, fine, write to etcd and use it as a cache, but you don't automatically reconcile or automatically assume when you come back up you're still owning that device. You go to the core says, this is the device you own, and if so, then you can use the cache if it's available, else you get it from the core. So I think I agree with you. I'd like to see the adapter be much more, what I want to say, a blind worker, right? The adapter just does what it's told when it comes up. It gets its instructions, it goes on. But that's a bigger discussion I think we need to have.
Yeah. I think what you outlined before, David, is a good suggestion. Let's go with that for now.
If I did it, it's surely not a good suggestion.
Oh, come on.
What is this? Just the incremental step where we're not actually changing much right now. We're just, the adapter drives things, but there is a exponential back off in the core based on the error state.
Yes.
I think that's the first step that does minor changes, and it's probably a relatively easy fix, although there is state in the core. But I do think we need to discuss what Chip was talking about, because I think it's probably the right solution long term.
Yeah. I mean, if you think about that, then when an adapter comes up, he waits for the core to tell him what he can do. That leaves the old step of the core could also tell an adapter to abandon a device and ask another handler, another replica to handle it. And that might be a way to do an upgrade of a device adapter, how you age out an old adapter and do something that's near hitless to the customer.
I agree, and as you alluded to, it also solves a problem that when the core gives up on an adapter because it hasn't heard from it in days and reassigns that work, it means you don't got two people trying to manage the same device. Yeah. The adapter actually comes back up. I think it solves a lot of problems.
Sure, but I think as a first step, this is what we need. well, what you outlined, David, is what what I would like to start with. And then we can definitely ask the folks from the adapters to take a look at that and just give us our thoughts. It should be a pretty straightforward patch.
In this patch, just to be clear, the reconciliation is started from the core. Is that still the case?
No.
No, the reconciliation is, there is an assumption that the adapters actually start reconciliation today, both OLT and ONU. That probably needs to be verified.
Well, the state wasn't there, so the patches for the adapters are not there.
Okay.
Oh, now that's the state works.
No, but when an adapter comes back up after restart, in the current mechanism, the core invoke the reconciliation for each device that the adapter support. Are we changing that in this implementation?
No, it's just state reporting. The call will still be done by the core. It's just that every time we call reconcile device, the adapter will update the state.
Okay, so the only change would be that the core will not change the operational state to reconcile. It will be the adapter that changed that state.
Yes.
Okay.
But that's got to be a patch to the adapter still, because the adapters don't do that today. What happens today when things come up? The adapter doesn't, you said at least one adapter tries to reconcile before it changes the state to operational. What happens if that reconciliation fails?
Not sure. I will have to check. I think the device is never moved out of some state. I forgot which one it is. I have to check. I don't know.
I don't think anything happened because we don't have the reconciled state. So it's the different states at the state what was state it was.
Yes, exactly. It will be left in the state that it was.
Okay.
Okay, guys, given that we are at the top of the hour, there's just a couple more things that I wanted to bring up. And I would like people to start thinking about this, and we can talk about it next meeting. One is the move to Golang 1.16. We are currently at 1.13. And for the LTS release, it might be best to move to 1.16. I'm not aware of any drawback of this. Just give it a think, and we're going to talk about it next week. Also,
can we discuss it before next week? Just use Slack channel or whatever. Or do we have to have a?
Sure, we can discuss it on Slack. Okay. Please send your thoughts on the vOLTHA dev channel. The other two things, two documents from Circuit. One is a use case of the new auto registration, where it like goes back after after it goes away and it comes back. There is some procedure that Netsia would like to happen. Please go read the document. I don't want to go into detail right now. And also an initial proposal from Mahir, if I'm not mistaken, on multi-uni support. So again, please go read these documents. They're here. Just go through them and see and give us your thoughts on them. And I'd like to discuss these in the next meeting. And also, if you have the time, go through the patches for the MEF versus IETF definition. There's still some comments on one of them. I will make sure to get them addressed this week, and also because this is also somewhat of a major change, especially for testing, and I want to get it done as soon as possible. Okay. Thanks, everybody. I'll talk to you
just
next.
one thing.
Oh, sorry. Go ahead, Theo.
The Golang 1.6 discussion, can we keep it on the mailing list so it's easier for people in different time zones to keep up?
Yes. Okay. David, do you mind sending an email out?
I will absolutely send an email out.
Thanks.
Sure. Okay. Thanks, everybody. I'll talk to you next week. Cheers. Bye-bye.
Okay.
Bye, guys.
Bye, everyone.